The James Webb Telescope makes first unequivocal detection of carbon dioxide in an exoplanet atmosphere. This is by University of California, Santa Cruz, phys.org. For the first time, astronomers have found ambiguous evidence of carbon dioxide in the atmosphere of an exoplanet, a planet that is outside our solar system. The discovery, accepted for publication in Nature magazine, posted online yesterday, August 25th. It demonstrates the power of the James Webb Telescope, JWST, to deliver unprecedented observations of exoplanet atmospheres. Natalie Batalla, professor of astronomy and astrophysics at UC Santa Cruz, leads a team of astronomers that made the detection using JWST to observe a Saturn-mass planet called WASP-39b, which orbits very close to a sun-like star about 700 light-years from our Earth. Previous observations of this planet with Hubble and Spitzer had given us tantalizing hints that carbon dioxide could be present, Batalla said. The data from JWST showed an unequivocal carbon dioxide feature that was so prominent it was practically shouting at us. Carbon dioxide is an important component of the atmospheres of planets in our solar system, found on rocky planets like Mars and Venus, as well as gas giants like Jupiter and Saturn. For exoplanet researchers, it's important, both as a gas that they are likely to be able to detect on small rocky planets, and as an indicator of the overall abundance of heavy elements in the atmosphere of giant planets. Carbon dioxide is actually a very sensitive measuring stick, the best one we have for heavy metals in giant planet atmospheres. So the fact that we can see it so clearly is really great, said co-author Jonathan Courtney, professor of astronomy and astrophysics at UC Santa Cruz, the director of Other Worlds Laboratory. Stars and gas giant planets are made primarily of the lightest elements, hydrogen and helium, but the abundance of heavier elements, what astronomers call metallicity, is a critical factor in planet formation, Fortney said. The ability to determine the amount of heavy elements in the planet is critical to understanding how it formed, and we'll be able to use this carbon dioxide measuring stick for a whole bunch of exoplanets to build up a comprehensive understanding of giant planet composition, he said. Batalla's team observed WASP-39b as part of the JWST early release science program to study transiting exoplanets. A transiting planet passes in front of its star as viewed from Earth, enabling astronomers to analyze the starlight that passes through the planet's atmosphere, where gases like carbon dioxide absorb certain wavelengths of light. Using the near-infrared spectrograph NIR-SPEC on James Webb Telescope, the team obtained a high-resolution transmission spectrum showing the light transmitted through WASP-39b atmosphere separated into its component wavelengths. Batalla said the data yielded exquisite light curves and showed that the NIR-SPEC instrument is exceeding expectations for transmission spectroscopy. This bodes well for the observation of small rocky planets, which are expected to have carbon dioxide in their atmospheres, when they have atmospheres, that is, but won't give us a strong signal as a giant planet like WASP-39b. This detection will serve as a useful benchmark for what we can do to detect carbon dioxide on terrestrial planets going forward, Batalla said. It's the most likely atmospheric gas we'll detect with James Webb Telescope in terrestrial-sized exoplanet atmospheres. In addition to carbon dioxide, the researchers detected another interesting feature in the spectrum of WASP-39b that they have not yet identified. It's a mystery feature for now, Batalla said. In this paper, we focused on a narrow range of infrared colors. This is only a preview of the features we expect to see in the full spectrum. Fortney noted that WASP-39b appears to have a similar composition to Saturn. Saturn's metallicity is 10 times that of the Sun, and WASP-39b also seems to be enriched in heavy metals, elements about 10 times relative to the Sun. That's super interesting, and we would love to know if all Saturn mass planets have the same metallicity, he said. It was exciting to see this in another system because we did not know what to expect when we went from the planets in our solar system to the atmospheres of exoplanets. Located in the constellation Virgo, WASP-39b is more than 20 times closer to its star than Earth is to our Sun. Although it is about the same mass as Saturn, it is less dense and about 50% larger, probably due to heating from being so close to its host star. Previous observations showed it to have relatively clear skies, making it a good target for transmission spectroscopy. When the first data from James Webb Telescope were released in July, the USCS exoplanet researchers were hosting 45 visiting astronomers from the Other Worlds Laboratory annual exoplanet summer program. Batalla said, "We were all huddled around the laptop getting our first look at the spectrum and marveling at it. It's a tremendous, almost euphoric feeling, seeing something for the first time that no other human being has seen before. It's what science is all about." This is by University of California, Santa Cruz on phys.org. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.